Now directly below, this says the number of solutions to linear equations and the conditions for which they occur. So when can we get one solution? When can we get that? Well, if you have a line and then you have another line, that's an option where there's one solution. Sorry. What else could happen? Well, I guess you could do what we did just had, where you have one of these, and then you have this. So one of them bounces up and goes through. What is something that has no solutions? So you could have, it's possible to have no solutions. And that looks like parallel lines. If you had two things that are parallel, that never get closer to each other, they just keep staying at the same path, that will get us no solutions. Infinite number of solutions. So that sometimes happens. That happens when you've got a line and then you get a line right on top of that. So that's a possibility. And of course you could have the same thing with absolute values, where you've got a line that bounces up and then the same thing bounces up. You can get two solutions. That's the only way to do two solutions with lines is if you have an absolute value. Because if you just had a normal line going through and then you had another line just going right through, it doesn't really matter. It only ever crosses the red thing once. It's only if the absolute value, or so we have an absolute value, that we have an option of crossing through twice. So something like that, where you end up getting two solutions. So you can have 1, 2, or 0, 1, or 2 solutions. And then of course you can have the infinite number if you have the exact same thing. It wants to know in example 2 now, how can we solve these algebraically? So with algebra, it's actually very straightforward. Step number 1, if you're going to write down steps, step number 1, I'm not going to write it, but you can, get y alone for both equations. So for equation number 1, so yeah, you can pause it if you want to write that. But for question number 1, it's already done. Y is by itself. For equation number 2, I need to move this 7 over to this side. So I've got y equals negative 3x and then minus 7. So I've got both equations now are set equal to y, where y is alone. And then what we want to do is set y equal to y. We want to set both y's equal to each other. We want to say, hey, I want this first equation to equal the second equation. That's what we were doing in all of these. Graphically, we were trying to find out when do these y's, what x gets us these y's where they'll cross. They cross out in here, the y height is 2. So we wanted to find out what are the x to get them matching y's. We wanted both y's to be 2. And so here we want to get matching y's, so we set the y's equal to each other. Now the red y is actually, you can write y, but you can also write 1/3 x plus 3. So I'm going to write 1/3 x plus 3. And the other y equals the other y, negative 3x minus 7. So we have y equals y, and then we have the 1/3 x plus 3 must then equal negative 3x minus 7. So we get both equations equal to y, and then we make them equal to each other. And then this turns into a pretty normal equation for solving. You want to get the x's alone on one side. Now the only thing that's awkward about this question is that there is a 3. Like a third, there's a 3 on the denominator. So what you can do for something like this is just get a common denominator. So I'm going to times this by 3, 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 times this by 3. So I've got a 1/3 x. Sorry, something happened there. Let me try it in here. I've got a 1/3 x plus, this is times by 3. 3 times 3 is 9/3 equals 3 times 3 is negative 9x over 3 minus 21 over 3. And then when you have a common denominator, you can put them together. So you, on both sides, 1x plus 9 all over 3 equals negative 9x minus 21 all over 3. And then there was this trick that we had to do where we could multiply the right side on the numerator and the left side on the numerator by whatever the denominator was, where we could cross those off. So I have 1x plus 9 equals negative 9x minus 21. So there's a bit of a hiccup there. We set the equations equal to each other, and normally we can just run with that. However, this one had a 1/3, so I made all these over ones. The denominators ones got a common denominator of 3, put them together, and then got rid of the denominator by multiplying the left side and right side by 3. And now I can actually bring this 9x to the left because it's a negative one, so I might as well bring that one over to the left-hand side. And if I do that, I'm going to minus this 9 at the same time over to this side. So 9x plus 1x is 10x is equal to negative 21 and negative 9. That's negative 30. And then I can divide by 10. Divide by 10. X is equal to negative 3. Perfect. So x is equal to negative 3 is if I put a negative 3 into the equation, into this one, or into this one, I should get the exact same height. And so I don't actually need to do that to prove that they're the exact same height. Usually this is fine. Sometimes they will ask, well, what is the y? So if that's ever the case, if they wanted to say, well, look, you found the x, there's an x comma y, you found the x was negative 3, but what is the y? If they ever ask for that, well, then you can just pick one of the equations. So y plus 7 equals negative 3x, and you can put whatever your x value is in. So you have y plus 7 equals negative 3x, and your x is negative 3. So you have y plus 7 is equal to negative 3 is 9, and then you'll minus the 7 over, and y is equal to 2. So our answer, I guess, in an x comma y form is the x is negative 3 and the y is positive 2. So it depends what the question is asking for. It's just worth noting, why did I choose this equation? Y plus 7 minus 3x. Why did I choose this one in order to find y equals 2? Why did I not put the x value into this one? And the only reason I did the second one there is because it didn't have a fraction. So it doesn't actually matter what you choose, you just choose whichever one is easier. So let's look at letter B here. Y equals negative 2x plus 1 in absolute values equals this. Step number 1, get y alone. Well, that's already done for number 1. And the second in the system needs me to move over this x. So y is equal to x plus the 1. So those are my two equations in my system. Now I need to make y equal y. And so I'll have negative 2x plus 1 is equal to x plus 1. And the negative 2x plus 1 has to be in absolutes. Now it's worth mentioning that letter A is a grade 10 question. So we would have done this in grade 10. It's a linear equation. So grade 11 is where we add now absolute values into these things. Now this question now becomes an absolute value question, which we did in the chapter just before. So in order to solve these, you can't just get the x's alone like we could in the previous one. You have to say, well, the inside, negative 2x plus 1, I'm okay if that equals the original, x plus 1. Or the inside, I'm okay if that equals the negative version. So a negative x and a negative 1. From there, I can just solve it. So I'm going to add this 2x over to this side. And then at the same time, I'm going to minus the 1 over to that side. So 1 minus 1 is 0, and x plus 2x is 3x. Or I'll divide by 3, divide by 3. X is equal to 0 over 3, which is 0. So I found one of my x's, And the other x I will do here, I'll add the 2x to this side to get rid of it. And at the same time, I'll add 1 to this side to get rid of it. So 1 plus 1 is 2. And then 2x minus x is just a 1x, or just an x. Oh, and that's done. So I have x equals 0 and x equals 2. Now I could ask for you to find the y's, in which case you could plug those back in. You could choose any one of these and find the y. So you just take, say, this bottom one, plug 2 into there, bring it to the other side, and then plug 0 into there, bring it to the other side, to 0, though you don't need to bring things over. So you could do that, but it also, I'm not going to ask that, or at least I don't know. I don't think I'm going to ask that right now. But what we do need to do is whenever you have an absolute value, you had to do a check. So did 0 work? So you put 0 and did 2 work? So you put 0 into the original equation. Now not into the original equation here, but into the original equation that you created when you made this system, set them equal to each other. So I put 0 in, so negative 2x plus 1. In this case, it's negative 2, 0 plus 1 in absolutes equals x plus 1 or 0 plus 1. Now 0 plus 1 is 1, and negative 2 times 0 is 0, and so you just get the absolute value of 1. And the absolute value of 1 is 1, and 1 equals 1. Yeah, so that's good. Now you put 2 in, so negative 2x, which is x is 2, plus 1, is equal to 2 plus 1. Is it x plus 1? Yeah, it is x plus 1. Perfect. So negative 4 plus 1 is negative 3 in absolutes, and 2 plus 1 is 3. The absolute value of negative 3 is 3, and 3 just carries down, so 3 equals 3. So there you go. So yes, it works. So 0, x equals 0 is a good answer, and x equals 2 is a good answer. And you could, if you want to, find the y's, but for here, all I want you to do is just, for all these questions, I just want us to find the x. What x would get you the exact same y? The last question is another absolute value question. So get y's alone, that's already done. Hopefully you can see a bit of a pattern after I'm done this. Get y alone, I have to do 5 over to here. So y is equal to negative 3x plus 5. That's my second one, and this is my first one. And then I can set y equal to y. So in this case, I'll have an absolute value of 2x minus 5. That's one of them. That's the first one. Equals the second one, which is negative 3x plus 5. Now, it's an absolute value equation, so you need to get the absolute value alone, which I've done. So option 1, I'm okay if the inside, is equal to negative 3x plus 5, the original one, or I'm okay if the inside equals the negative version, which in this case would be a negative 3x or a positive 3x, and then instead of a plus 5, a minus 5. So these questions now I could just solve. I'm going to move this 3x over to this side by adding it. And then in the same line, I'll move over the 5 to the other side. So 3x plus 2x is 5x equals 5 plus 5 is 10. So then I can divide by 5. X is equal to 2. On the other side, I can move the 2x over. I can subtract the 2x over to the right, in which case I'll add the 5 over to the left. So I have negative 5 plus 5, which is 0, and 3 minus 2, which is just an x. So 3x minus 2x is just x. Okay, so there I have it. So I've found my two x's. X's are 0, and x can be 0, or x can be 2. I think I just have to actually do the check. So the equation is absolute value of 2x minus 5 is equal to 3x plus 5. Okay. Oh, and my x is 2, so 3x or 2 plus 5. And over here it was a 2x, so 2 times 2 plus minus 5. Okay, so 2x minus 5 or 2 minus 5, and 3x plus 5 or 3 plus 5. 2 times 2 is 4, 4 minus 5 is negative 1, so negative 1 is on the left, but in absolute values. And 3 times 2 is 6, 6 plus 5 is 11. Okay, that's not going to work. Did I actually copy this down? No, I did not. Okay, so it's a negative 3x. Okay, good. So negative 3x, or negative 3,2, is negative 6 plus 5, which is negative 1. And then the absolute value of negative 1 is positive 1 equals negative 1. Okay, that still doesn't work. So that is not an answer. We have to reject that. And then in this system, I've got 0 as an option. So the absolute value of 2x minus 5, or 0 minus 5, is equal to negative 3 times 0 plus 5. Now on the left here, 2 times 0 is 0. So I have 0 minus 5, which is minus 5. And on the right, I've got negative 3 times 0, which is 0. 0 plus 5 is 5. The absolute value of negative 5 is just 5. Okay, so that works. So if you we need to just state, okay, x equals 0 is the only answer because we needed to reject this one. And if I needed to find the y value that go with that, you would just go back to the top here, pick any of the questions and just plug 0 in. So if you chose the first one, for instance, 2x, 2 times 0, so you have 0, 0 minus 5 is minus 5 in absolutes, which is a positive 5. So our y would end up being positive 5. But for now, all I want you to do is just find out which x's work. So just to recap all of that, the example 2, letter A, that is a grade 10 question. You get the y's equal to each other, and you find that it's just negative 3. B is a grade 11 question because it's got absolute values. So you set the y's equal to each other. The solving becomes a two different equations to solve because it's an absolute. You've got the original version and the negated version. The same with C. There's an absolute value. So you set them equal to each other, and then you have the normal version and the negated version. And then once you get your answers here, like on A, once you got your answer, you were done. But here, because absolutes, you got to check them. And those both checked out okay. This, however, on the right did not check out okay. The x equals 2 had to be rejected. So I'll zoom out there for you to copy anything you need to copy. But moving forward, even if my answer key shows what y is, it's good to know. You don't have to find y.